first problem in our meeting was my name. Is it because previously all 8 problems are, all need your calculations, but I think maybe it's too tough for you, so I just delete one problems. But if I need to change all the numbers, I need to change 7 numbers. So it'll be a little bit tough for me. So I just change, adding one useless, meaningless questions, which is my name. Okay, but I hope everyone can know my name. It will be better. OK， 有开冷气吗？没有，对不对？对。可以请帮我看一下吗？我不知道怎么看。好，我们去上课啦。谢谢，谢谢。Okay, so let's continue our lecture. Right. So last time we talked about 6 tips. Okay, 6 conclusion that the change in shear force are related to the point load and distributed load, and the slope will be related to the distributed load, and the slope of the bending moment is the shear force, and the change of bending moment are the area of the shear force diagram, and the change in moment in the magnitude of the will equal to apply the bending moment. Okay, so there are 6 tips that help you to solve this problem really quickly. Okay, so last time we have a new problems here, and can I write it down here? Okay, and this is distributed load in the middle. Okay, let's continue. So before that, I need to solve the RA and RB. So last time we solved RB. This time we solve RA. Sigma Fy equal to 0, and RA minus QB plus RB equal to 0. So RA equal to QB B plus 2C 2L. So you see they looks very symmetry, don't you think? Okay, so let's start to draw a shear force diagram and the moment diagram. Okay, 2 figures, and the first one is V and the other is M. Okay, and this is X, and this is 0, 0. Okay, now if I were you, I will definitely know that there are 2 sections that we can draw section line here, right? Because at this section, at this intersection, the force distribution changed, right? So there must be 2 sections here. Well, 3 sections, 2 section lines. Okay, so let's start. RA, point load upward, so make it the shear. RA, no problem, because the change in shear is the magnitude of the point load. RA reaction force can be treated as a point load. Okay, up. So up RA and nothing change. So maintains equal volume, constant. Okay, now you can see that the change in the shear force is the area of the distributed load, because we met a we meet distributed load at this point, right? So this area QB will be the change in shear force within this range, right? So RA minus QB will be these section, the change of shear in this section. So RA minus QB, what will it be? RA minus QB. Did I wrote it? But don't worry, because RA minus QB will be negative RB. After you RA minus QB will be equal to minus QB. Okay, definitely. You can try that. QB minus QB. Sorry, minus RB. And the range, the change is QB, right? RA minus QB equal to minus RB. Okay, then let's take a look how to connect between the 2 points, these 2 points. So you notice that every section, for me, I just starting point and end point, and then study how to connect them in between. So that's the procedure I always do, right? So how to connect them? So the slope of the shear force diagram is the value of the distributed load at the point. Oh, so the slope will be equal to the value of this distributed load, Q. So it will be a straight line, because there's the only one constant Q, right? So it must be a line, right? So now, what will it be for this X1? Because A are not equal to C, so which means that RA and RB are not equal, right? So which means that this is not half of L, right? So this area won't be the same, because we don't know A and C's relationship, right? So green and blue, they don't know. We don't know. We are not sure they are equal or not. Well, they are not equal. Okay. Okay. Then so let's continue. So how to solve that? How to solve that? Let's do it. So we can have a similar triangles. Similar triangle. It will be 不明了 RA allergy. Sorry, excuse me. RA RB divide by B equal to RA divided by X1 minus A. Understood, right? X1 should be this, okay? So be careful. So X1 minus A will be this one, okay? So let me draw a like that. Okay, these similar triangles can provide. Sorry, I should make it bigger. X x1 equal to a plus b plus 2c divided by 2l. Okay, so we will use that later. Okay. Um. Well, sorry, I should. So this is the. Okay, this one can tell us what is the point of the x1. 啊，对不起，我需要擤鼻涕。看我已经非常的有经验了，我知道我有的时候会被破点。OK，有了的。Okay, so let's continue. Okay, and RB. So we know all the information here. It's okay. So let's continue. Next, this one is there's no value here, right? So you can imagine that is sorry, just unchanged. Okay, unchanged. Done. Shear force diagram done. How about moment diagram? Moment diagram. A and B, the support on at A and B's are hinge and roller. Hinge and roller cannot resist moment, right? So there will be no moment, reaction moment at A and B point. So we can definitely sure that they are zero. And then what is the value change in moment within this section? It will be the area of the shear diagram, right? The change of bending moment is the area under the shear diagram. Okay, so the area here will be RA times A. RA times A. So RA times A times A. Okay. And how can we connect them? The slope will be the same because the moment diagram, the slope of the bending moment diagram is the shear force value. The value will be the same, I. So it will be like this, no problem. Then we notice that we have another section occurred because the shear diagram has one more section. This one, right? Because it changed the kind of change the face. Okay, change the situation, the conditions. So let's continue. Let's see this section. So the change of the shear diagram, moment diagram will be the area of the shear diagram. So what is the area? The area will be how can we do that? Dun, 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 dun. Okay. Dun, 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 dun. So the area will be RAB squared to BC divided by 4L, right? Because we just has the value of x1, right? Minus A should be this length and times RA. So we have RA, this one, okay? And the value. Okay, the difference. Okay, the change of the moment diagram, in the value of the moment diagram will be equal to the area of the shear force. So the blue part, I wrote it down here. How to connect them? Good. I believe you understand how to do that. You see, the slope of the bending moment diagram will be equal to the value of the shear force. So you see, the shear force decrease from RA to 0. Okay, so you will have a steep slope first and then become flat, 0 slope. Okay, so you can see that RA and 0 slope here. Okay, so you connect them, and also the value of the slope is decreasing, so you cannot draw a straight line. It will be a second order curve. So okay, so steep and then flat. Okay, next we need to draw another drop because of the negative area value here. What is the value? Which will be minus RB times A plus B minus X1. Okay, so it will be RB minus A plus B minus X1 divided by 2, because this is a triangle. Okay. Okay. So this is the uh hmm. Okay. Next one. Again, this we get the value, right? And um how to draw the connecting these two dot, initial dot and final dot, how to connect them. We use this the slope of the moment diagram will be the value of the shear diagram. So shear from 0 to negative, 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 more negative. Okay, so it will start from the flat slope 0 and then steep value as RB minus RB. But and you notice that this minus RB will be negative slope. So okay, how about next one? It's we connect the final dot from here with the constant slope. Constant slope. Okay. 有点难画了。It's a little bit difficult because you need to satisfy all the constraint. Okay. Okay. So you can see that this slope equal to RA. This slope equal to 0, and this slope equal to minus RB. Okay, that's it. So this is the this question, this problem. I hope you understand what I'm talking about. You need to do that because you need to understand that because chapter 5 need this one first. 一美红茶又便宜又好喝，很棒。它还有卖减糖版的，就没那么好喝。哦，I noticed that I miss one small part. Okay, because I skipped that for the RB value. RB value. I forgot to do that. I write down here. Okay, how to get the minus RB. So I should write down like this: V at x equal to a plus b. So which means that this one. Okay. Okay. I should write it down. So the R minus RB should be RA minus QB, right? So RA minus QB, right? The QB, QB, how to do that? QB, yeah, minus QB equal to minus QB square minus 2QAB divided by 2L. And then you notice that the value is actually equal to minus RB. Okay? Okay, so you actually notice that this value is actually equal to this one, right? So that's the reason why I gave the negative RB here. Okay, so because there are too many equations in my script, so I missed that part. I'm sorry for that, but I believe you know how to do that. RA minus QB equal to minus RB. That's why. Okay. Sorry, I forgot this part. 听懂吗？就是我忘记把这个式子写出来了啊，因为上面太多式子了。那我补充一下，它为什么是负 RB？当然了，你不用算这么辛苦也可以啊，你直接从你看那么久了，你都知道这边这个 RB 一定在最后面，一定在下面，然后你就哎，没关系，想想看。如果你看不出来的话也没关系，就是照我这样算。但是你越做越多的时候，你就会知道有些点根本就不用算，你直接用推过去就可以了。So I believe you notice that when you see the RB and RA here, you can probably know that this is the initial point and the final point, and also the end. Okay, so it is you need more practice. Next one. Next one. 我不知道是怎样，就是可能是我的 Facebook 吧，都会推那种年龄层的广告什么。 最近我 Facebook 全部都在推不够善良的我们，有听过吗？没有对不对哈？因为你的 Facebook 不会推播你，因为你们不是那个年纪的人。因为那个东西好像是在，它不是好像，它是在讲，就是我这个岁数的，它里面的主角就是我这个岁数的，所以你们不会，你们没有被推过这个故事，你不知道这个连续剧吧？有听过吗？有听过？你们有被推播哦？很少啊啊，没有被推过，对不对？所以你们推过的是什么？寄生兽，不然是什么？OK, so let's continue. 所以我觉得现在这个演算法很恐怖，他看到他就推给你，他觉得你想看到的，哦，很厉害哦。OK, next one. 呃，嗯，P. OK, let's do it. 等一下，等一下。Q. Sorry, I guess this is repeat. This is repeat one. I'm sorry, I should delete that. This one is deleted, right? Should be deleted. The same. Okay, so next one. This one, okay. Finally, you found that there's something different, right? With the fixed n, P1, P2. Okay, something like that. Okay, so what is the support looks like? The support is fixed n, so it will have RB, right? And also horizontal, right? But there's no horizontal force. So there's no, the horizontal reaction force will be equal to 0. So I just neglect that. And the most importantly, moment, okay? So I assume that this is, assume a moment here, okay? And you notice that I assume counterclockwise, okay? Because when you do this solution, solving balance of the force, we use the moment counterclockwise as positive, right? So we assume positive moment in counterclockwise direction, right? In force balancing equations, okay? So we assume this I call MB. So let's continue. Sigma Fy equal to 0 is easy, okay? So minus P1 minus P2 plus RB equal to 0. So RB equal to P1 plus P2. Done. And then next one, sigma M. Okay, let's take a look. Dot. Where's the dot? This dot. Okay. Equal to 0. So P1 counterclockwise, so it should be positive. P2 about the blue dot is counterclockwise, also P2 plus B. And MB itself is positive, as we mentioned. So everything will be negative V1 and negative B2. So which means that, okay, actually MB is minus. So which means that my my assumption was wrong. Okay, so it should be has a reaction moment at in clockwise. Okay, right. So let's continue. Continue. So after we solve the reaction force, okay, so this is X, this is V, this is M, okay? M, and this is 0, 0, okay? So let's continue. Firstly, easy, minus P1, downward, right? Because the shear value change will be the point load value, minus P1. Okay, nothing changing in between. And P2, oh, further, downward further. So it will be minus P1 minus P2, and nothing change in shear. Okay, so imagine that, wow, this is a really interesting shear diagram, right? Interesting. Next one, moment. Moment, where should we begin? You see, A is a free end, so there's nothing can do there. So there's no moment for reaction moment, right? So should be start from 0. And this section will has a value drop, value decrease, which is the area of the shear force, which is minus P1A, right? The value, the area. So this is minus P1A. Okay, how to connect these two dots? Because the value of the shear force is constant, so they connected by a linear slope. How about next one? The section between this section, moment will drop. How much? It will be equal to the area of the shear diagram. So this is minus P1 minus P2 times B. So the value will be a minus minus P1 minus P2 B divided by no, just like that. Okay, so what will be the value? The value will be this one minus plus this one, right? These two. So the total height will be minus P1 minus P2B minus P1A equal to minus P1L minus P2B. So this is the value of that. And we know how to connect that is this linear slope. So, okay, done. And you notice that this value, don't you think is equal to this one? Right? The final point, the reaction force for that. Okay? The MB here is downward. Downward, right? It's downward. And it makes this cry, right? 哭哭曲线. Okay? That's it. So I will refer you to check a bit, okay, to see the relationship between them. Okay, this is the this is the questions. I quite like that because you can notice that the fixed M, what will it looks like? 我刚迟到8分钟。 那我可以补个5分钟吗？那就9:55下课好吗？这样很不好意思。好，当然如果你等一下等一下有课要赶着去，可以先离开没关系。我希望让我这个课至少也有45分钟之类的。然后 feel free 出去上厕所啊什么之类都可以。然后我只是想要讲完它，全部都走我也会继续录，没关系。好。Okay, so next I will continue our lecture for my extra minutes for extra minute because I was late. I'm terribly sorry for that. Okay, so this is easy. The next one will be the last one. The last one will be has a distributed load. Okay, distributed load. Q equal to 1.0 kN, and the most importantly, there is a counterclockwise applied N norm 12 kn.m. Oh, that'll be really difficult. I mean, so the first example for you, and you notice that A is a free N, and B is a hinge, C is a roller, and this is RB, this is RC. So let's take a look. Let's make the sigma, MC equal to 0. When we do the force balancing, we will treat the distributed load as a effective load, 等效力. Okay, so this is QB. Okay, 4M, 4 meter. So let's continue. So 1 times 4 QB, okay, times 18, 8 plus 8 plus 2, okay, because you see A plus 2, half of it, because they through the centroid, okay, times 18. And you see the QB rotates, C is counterclockwise, so this is positive. How about RB? RB is clockwise, it's negative. So it has minus RB times 16, A plus A, right? Okay. And how about MC? MC itself, N norm is counterclockwise, so it's plus N norm 12 equal to 0. So RB equal to 5.25 km, okay? And sigma Fy equal to 0, help us to determine minus 1 times 4 QB, right? Plus RC plus RB, which is 5.25 kN. So RC equal to minus 1.25 kN. Okay, so which means that our assumption was wrong, right? Our assumption was wrong. So the RC should be downward, right? Okay. RC should be downward. Right. Now, 3 minutes later, I will give you a free time. So you will notice that next week, Tuesday, I will proceed to chapter 5. Okay, chapter 5 will be the most difficult chapter in this course. Most difficult, most complicated. So be careful about this, okay? So this x0, 0, v, m. Okay, so very easy for you. Sorry, I need to draw another section here, right? Another section. So the first section start from free end. Free end will always has zero shear, right? Zero moment. And the roller will always have zero moment. Again? Okay, so we quickly just see the picture and we can just draw the dot. And then let's see how much will be decreased within this section. How much in shear drop will be the area of the distributed load. Area will be QB. So the QB is 4. So it will be -4. Okay, how to connect that? The shear slope will be equal to the distributed load value, right? The value will be Q, 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 Q. So it's a straight line. Okay, and then RB will go up. RB will be 5.25. So 5.25. 5.25. So this is 1.25 here. And then you notice that there's nothing in the load in this section and the next section, and that's it. And you see RC downward 1.25. Okay, very matched. Okay. 哎，我讲了8分钟，好，不好意思，把这题讲完，好吧？不好意思，对不起，对不起，对不起。Okay, so next one, M here. Within this section, the moment will change. That value will be the area of the shear diagram, right? -8, -4 times 4 divided by 2, so -8. So this is -8. -8. Ooh. How to connect this? The shear force diagram value is from 0 to -4. So the slope need to be 0 and -4, right? And it gradually change. So gradually change. Done. And then let's take a look. How much will it increase for the moment in this section? Will be the area of this. The area here is 1.25 times 8. So it should be 10. Okay, plus 10. So -8 will jump to plus 10. So it should be 2. Right? And then how to connect them? It will has a constant value of the shear. So the moment slope will be a straight line. Then you notice that it has a external moment. Be careful. Moment here. So let's draw a here to here. Okay, so here is the M norm. So what will it be for this one and this one? Because the M norm is counterclockwise, we need to balance it. So we need to have a clockwise to balance that M norm, which is 12. We need to balance that. So which means that this one M, we draw the value here, will be negative. So after it passing through 12, it will become negative 12, negative 10 because minus 12. Okay, so this is minus 10 downward. Okay, and then you will go back to 0 with a straight line. That's the all of how to draw this. This is the end of the chapter 4. Okay, I believe this. I spent 8 minutes for this one. It's a little bit quick. No problem. I will resume. I will summary this problem next Tuesday. Okay. Thank you very much. If you have any questions, just come here to let me know. Thank you. Oh,好，谢谢，谢谢，谢谢。Okay.